Let's get started with part 3 of the lab, which has to do with paleomagnetism and the ocean floor. So this is going to be similar to the first part, where you're going to measure distance and time in order to see how fast the ocean floor is spreading. But instead of just a map of color ages, you're going to be using some data on when these paleomagnetic reversals have taken place. So 2 parts to this. What you're seeing at the top is a map, and this is showing a divergent plate boundary. The axial rift, the axial valley, is right down the center here where it's M. So this would be the present day time. This would be time equals 0. And in the past, the ocean floor has spread out in both directions from here. So we can see kind of a symmetrical pattern here. I have a thick line, a space, a thinner line, a thick line, a space, a thinner line. And that's showing when the reversals took place, how long ago they took place. So the present time, so this is in time now instead of a map. Normal polarities are shown in black, and we're in an age of normal polarity. The last time it flipped was about 730,000 years ago, or 0.73 million years ago. We might be overdue. And it also shows the intervals of reverse polarity in white. So we can see before that we had reverse polarity from 730,000 years ago to 920,000 years ago. This is always happening, and from a geologic standpoint, it's flipped all these times in the last 5 million years. If you were to take this and turn it on its side, you would see the same pattern here. So for example, going from the present back in time, a thick black, a medium white, a thin black. Here's the thick black, medium white, thin black, and then a thicker white, and the same on the other side. So for example, at time t, we can see we're going through this entire area here, and we're getting right down to this line here, which is at 2.48 million years ago. So let's just fill in time t on our thing over here. So the age in millions of years, once again, I think I said that was 2.48 million years ago at t. And if we wanted to do that in years, that would be 2,480,000 years ago. Is it the same age as something? Well, let's take a look. So if I were expecting it to be the same age as something, I'd follow the same pattern of thick and thin white line, white and black lines onto this side, and it looks like that's exactly the same age as R. So I'm going to put in a R there. And then to measure the distance, once again, you're provided a scale bar here. You can move that down. Sorry. You can move that down to here, and you can see that's over 100 kilometers. I'm going to note that it stops right on that first thin black line in the middle. Move it over again. And now I can see that it's 100 plus 25 plus maybe 5 more, so about 130 kilometers, let's say. So I'm going to type in 130 kilometers for the distance. And that's in kilometers. And remember how we convert from kilometers to centimeters? We add 5 more zeros. So 130, 1, 2, 3, 4, 5. And then I'm just going to put in commas as placeholders so I can read it a little easier. That's going to be 13 million centimeters. To calculate the velocity, we would divide the distance divided by the time. So I'm going to divide 13 million divided by 2,480,000. And that's equal to 5.2. So 5.2 centimeters is the velocity here. And once you calculate the velocity, you'll be asked similar questions about whether this is moving at the same rate. And you'll know it's the same rate if your velocity between, let's say, this point and this point is the same as your velocity between this point and this point. And also whether it's spreading symmetrically. So symmetrically, if the velocity between M and T is the same as the velocity between M and R, then it's spreading symmetrically. So you go ahead and complete filling in the table, and then you answer all of the questions here. And this one is similar to the other question, right? If things are moving apart in two different directions, it's going to be faster than one direction. For example, if you were in a car driving 60 miles per hour and a car was driving in the other direction at 60 miles per hour, even though you're both driving at 60 miles per hour, you're separating from each other at 120 miles per hour.